Okay, let's go through a brief example introducing particles on a slope. So first of all, we've got a block of mass 10 kilogram sliding down a smooth slope. Smooth slope means there's no friction to worry about, either like air resistance or friction due to the ground and the particle. The angle is 15 degrees to the horizontal. Draw a force diagram to show all the forces acting on the block. Calculate the magnitude of the normal reaction and the acceleration. So you've got acceleration and forces. You're going to use F equals ma in this question. So let's get started. We do a quick diagram here. So you're just going to draw some straight lines. So this is our slope, and then we've got a straight line there. So we know the angle here is going to be 15 degrees. We know we've got a particle here that is sliding down the slope. Now the mass of this is 10 kg. So we're going to show the force of the weight. Weight is in newtons, weight is m times g. So in this case, it's just 10g, so 10 times 9.8. We usually just write g. And then we know that there's a normal reaction that's going to be perpendicular to the floor. And then there are no other special forces acting on it. I mean, the 10g is just gravity. So what we want to do here is split these up into its components. So the 10g force can be split up into these two components. There will be a force going parallel to the slope and perpendicular to the slope. We know that this angle here has to be 15 degrees. So this is going to be 10g cos 15, and the other component is going to be 10g sine 15. So we've got our two components. The normal reaction is just going to stay there. And then we know that the things that are perpendicular to the slope are these two forces, and then the forces parallel to the slope. It's just this one here because there's no resistance to worry about. Normally, if there was resistance, it would be acting in the opposite direction like that, which might be friction or air resistance. So we need to show the examiner how we are resolving this. So the first thing, so we've done the diagram, so we've done the force diagram. We're going to calculate the normal reaction. Now, the particle might be moving down the slope this way, but it's not moving up physically vertically away from the slope. It's not flying into the air. And that's basically telling us that 10g cos 15 is equal to r. They are equal to each other because they're in equilibrium. So we can just say r is equal to 10g cos 15. Now in this case you might just use a calculator to work out what that is, and that's going to give you 94.7 newtons. Minimum 3 significant figures for A level at least. And then for part C, find the acceleration of the block. Well, we know that this thing is going down this way, so you've got a double-headed arrow just to show that it's accelerating. Just going to make that neater. And then we just can use F equals ma. So let's write the formula. Force equals mass times acceleration. Now the forces going down are 10g sine 15. Forces opposing motion are 0 because there's no friction, so you don't have to worry about that. Normally you'd subtract any friction, so we don't have that here, so we leave that. Is equal to mass. Don't confuse mass and weight. Mass is 10, and then acceleration is just a. So we're just going to do 10g sine 15 over 10 is equal to a. So that's just g sine 15. So 9.8 times sine 15, make sure you're in degree mode. You end up with 2.5, so it's 2.53642, and we're going to round that. So acceleration equals 2.54 meters per second squared. Smash the like button, hit subscribe.